super, super fast because you learned this a long time ago, but you may have forgotten. So I'm just double checking that we remember it. What do we know about any angles that sit on a straight line? What's 180? That adds 180. Okay, so be careful, please, that when you are talking about the angles, you don't just say they equal 180. You must say that they add up to 180.
What's the difference between degrees and radians?
Okay, that's a totally different question, sweetheart. Okay, you don't need to worry about radians. Okay. Right, so these angles would add up to 180. Now, sometimes, so we know that this one plus this one plus this one would give us 180. So obviously if we were given A and B and we were asked to find this missing one, we would do 180, subtract these two, add it together. Yes? Nice and easy. Now, sometimes I have people that have an extended line here, and then there's another thing going on down here, and they say, well, are these ones all adding up to 180 because they're all on a straight line? You all know not. Yes? So it's only where they meet at a point. And I often like to say, look for something that looks like a protractor. Okay, because you know that a little half moon protractor is 180 degrees. And those angles there add up to 180. Okay, just yeah. And at a point, drawing a full circle. Doesn't matter how you've learnt it. Yep, there we are there. Add 360. Tread the and. At vertically opposite angles, and you might, she says might confidently, trying hopefully, because lots of people forget it, you might get away with just saying they're opposite angles, but they should be called vertically opposite angles, even if they look horizontal. Okay, so they are vertically opposite angles, and so it would be these two, what do we know about those angles? They're equal to each other, yeah. Bless you. Okay, Tresbians, and for the triangle. What do we know about the angles in the triangle, Shayla? Nice. So the angles in the triangle add to 180. Again, don't say they equal 180, they say they add to 180. And I said on the right hand side, don't forget about I said that these triangles, and they will have, a little bit off. They will have two side lengths that are equal, which means that at the bottom of those two equal lengths, those angles will be equal as well. So it could be a situation where you're told just this one and asked to find this one. Well, that's because you know that this other one is the same as that one. Okay? So they won't necessarily mark it as being the same value, but you know that it will. Right? Now, as I said here at the bottom, remember when asked to calculate or work out, so the question will start off with calculate or work out. It means that you need to use these angle reasons to find the missing angle. You do not measure them. And most of the time, the question will say next to it, not drawn to scale. It should always say it, but it doesn't always. But it means that you need to use these geometrical reasons to establish the missing angle. So I could tell you that this angle here was 83 degrees. Well, this angle here is nowhere near 83 degrees, but because I have labeled that 83 degrees, that's 83 degrees. Okay, does that make sense? So you just have to accept what, don't say, oh, but it looked like it was 90 degrees, so I wrote 90. That's not going to be good enough. I've said here, you must also learn the reason for the angle being the way it is. Sometimes there will be questions that they give you, and they only allocate a mark if you've given the correct reason as well. So it's all well and good if they have this as being 123 and asked you what this value was. You could say quite happily A was 123, but if you didn't give a reason for it, then you're not going to get that mark. Yes, but you can write it in shorthand. So I would probably just write or they are vertically opposite, or vertically opposite. That's sufficient. Okay? As long as you're getting across the message that you know why. Please also be aware that the reason, they ask for the reason, that doesn't mean the calculation that you've used. Alright? So if, for example, we had this one, oh no, that's a silly one. And if we were doing this one up here, and I was asked to find this one, and I know this is 30, and that's 50, because they're easy numbers. I would find this angle here, because I would do 180 subtract 30 and 50. And so I would know that my angle was 100. Okay, that is not my reason. My reason is that the angles add to 180. So my answer would be that x was 100, and the reason is that the angles add to 180. This calculation work is helping me find what it is. Essentially, you're saying, why did you subtract it from 180? The reason was because there were angles on a straight line. No, I don't want my angles out to 180. Angle on a straight line is simple. Angles on a straight line. Yes.
Would it, on the question, would it like ask you for a reason, or do you just always?
It should. What will probably happen is though they may say write the angle measure, give the reason for it, or they may say find the missing angle, explain your steps. So it will make it obvious that you need to give a reason. If they don't say anything and it's anywhere from mark, then you just write the number. So just it's one of those. Just make sure you read the question and the instructions. Okay. Right, I'll give you a few minutes to have a go at these ones.
Sure.
Right, so hopefully you got, I haven't checked these, I'm hoping that everyone's got the same answers. So we've got 163 and 62, and then 37 and 70, 65 and 50, and then 58 and 122. Now with this one there was a little bit of debate going on. Personally, and I know lots of people, they see, oh, angles at a point, I'm going to do 360, but to be honest, where possible, you probably want to try and look for straight lines and say, well, I know these two add up to 180. So if you establish they add up to 180, then you know those two are vertically opposite and you can find that one. So just be aware there are different ways of doing it. However, if you use two different reasons in your calculations, then you must give both of those reasons when you are giving the reason. Okay, so if you've been asked for the reason and you've used two different, you must give both. Alright, parallel lines, we show them with arrows. Parallel lines are lines which never meet and are the same distance apart. Okay, they never meet and they're the same distance apart. Okay, so the same distance apart is more important. You can sometimes draw lines that don't meet, but that doesn't necessarily mean they're parallel. Okay, so parallel lines are the same distance apart. Okay, they're usually shown with arrows on them. Sometimes one arrow, sometimes two. And if you've got a situation where you've got two sets, then one set might have one arrow and the other set might have two.
Wait, what do you mean they're the same distance apart? Should they just be
No, they always have to be the same distance apart from each other.
Oh, okay.
Yeah. Sorry. And right, so we've got alternate angles. Remember these? So here's my parallel lines. These two angles here are alternate to each other. Okay? And please try not to put that they're dead angles, because that's not the official name. You need to remember they are alternate angles. What do we know about alternate angles? They're equal, yes. And so it could have been these two angles here. Corresponding angles. Do you remember corresponding as well? Yes. Excellent. So corresponding, remember they're on the same, at this line here, do we remember what this line is known as? It's known as the transverse line. So if you've got parallel lines and you've got something going through it, that would be known as the transverse line. So alternate angles are on opposite sides of the transverse line. They're on alternate sides of the transverse line, but they could be squished in between the two parallel ones. Okay, so that's how you can remember alternates. Corresponding, if things are corresponding, they're the equivalent to each other. So they're on the same side of the transverse line, and they either hang down from the parallel lines, or they may go above the parallel lines. and obviously these ones would be on the opposite side below, and then the opposite side above. So just remember that they are hanging in the same direction. Corresponding angles are also equal to each other. So the word corresponding, you can shorten or whatever, as long as you're getting the message across to the person marking it, that you're not calling them Z angles or F angles, you're using the correct name, and you will be good to go. Can I move on?
Yeah.
Oh, is that one more down here? Co-interior. Okay, co-interior. They are within the parallel lines and on the same side as the transverse. They kind of make a C, co-interior. What do we know about co-interior angles?
They don't.
They are not equal yet. They add 180. Okay, so if there's both within and on the same side, then they add 180.
So only those two.
Yes, just these two angles. And it makes sense. I mean, the whole reasoning behind it is because we know that this angle here and this angle here are corresponding, and we know that these two angles add to 180. So that's why those two would also add to 180. Makes sense. Yeah. Have a go at these ones. Let's do it as quickly as possible. I've said to give a reason for your answer. Please give it. You don't need to show all of the working. You can do the working on your calculator, but do give the reason. Give a short version of the reason, so we're not taking too long doing this. Right, so angle geometry with algebra. I just want to go through a couple of these ones with you, because sometimes people look at these and go, oh, I don't know. Because there are letters and not numbers. You do these things exactly the same way that you set yourself up an equation. So what do we know about these angles here?
Equals 360.
They add up to 360. Okay, you've got to be really careful. They don't equal it, they add up to. So we're saying to ourselves, they add up to 360. So let's show that we're adding them up. 2x plus x plus 5x plus 4x would add up to 360. We formed ourselves an equation. We can see that we've got how many x's here? Whenever we have a situation like this, we would join like terms, yes? So I've got 2, 1, 5, and 4. So how many is that?
12.
So we've got 12 x's here. And then what do we do? Right, yeah. Is that what you said, Jamie?
Yeah, but I finished that there was 6 X on one of the straight lines. So it's doing 360 and then I did.
Oh, right.
Either way, I got
Okay. They haven't labeled this. What is it?
90 degrees.
Why?
Because it's right there.
Yep. Okay, good. So what do we know about this, and this angle?
The add up.
Yeah, so I mean, you've got a couple of different options. You can say 3x plus 90 equals 180 if you want to stick with the whole set task. Or you can just say that 3x is equal to 90 straight away. That's fine. And so x is 30. Well, that's what we say. 3x plus 60 will equal 180, yes? 3x is 120, x is 120 over 3, which is 40. Okay, straightforward, nice, easy. Too fast, Fiona?
Yeah.
I'm going to fly through this because this really is like the 7 stuff. I just wanted to make sure you remember. So equilateral triangles, 3 equal angles, 3 equal lengths. We show them at equal lengths by dashes on them. What does that mean each angle is? Which is? Which is? 60. But you have to remember that the equilateral triangle always has angles of 60. Okay, so that's something to look out for. An isosceles triangle has got 2 equal lengths. And which angles would be the equal ones? Okay, the ones at the base of those equal lengths, then known as the base angle. Right angle triangle has 1 right angle in it. Well, whose rule does it follow? Pythagoras. And we also, for right angle triangles, look at SOHCAHTOA, which is trigonometry. Okay, so that's to do with our right angle triangles. Scalene triangles have no equal lengths and no equal angles, okay, but their angles do add up to 180. A right angle isosceles triangle is an isosceles triangle with a right angle.
Oh.
Okay? So if you've got a right angle isosceles triangle, we know this one's 90. What do we know that these two must both be?
45.
45. Okay? So that's a special kind of a special kind of isosceles triangle where it's always 90 and two lots of 45. Okay? Angles in the quadrilateral. Shh. What's this shape known as?
Rectangle.
I think I've taken this from my year 7 notes. So, we know that the four angles in this quadrilateral are well, they're actually 90 degrees, which makes a total of 360. Is that true for all quadrilaterals? Yes. So if we were to cut any shape into triangles, we can see that we've got two triangles, so that means we've got two lots of 180. So they're always going to add up to 360 degrees. Okay, so the sum of the angles in any quadrilateral is always 360. Remember, a quadrilateral is any four-sided shape. It doesn't have to be a rectangle where all the angles are 90. Yeah? Okay, so you can do the bottom example while we're waiting. Alright, so we know that to find B, we would do 360. So B would be 360, subtract the sum of 130 plus 65 plus 95, which is what? 70. Which gives us 70 degrees.
Don't move. Miss Harrison.
Opposite angles in a parallelogram are equal. Right? What? Where's why? Oh, right. Okay. Next page. External angles in a triangle. You don't need to remember this rule, but it is quite handy sometimes. That this angle here is always equal to the sum of these two. Okay? So it's always equal to the sum of the two opposite angles. The reason being is that we know that these three angles would add to 180. So to find this one here, we would do 180 subtract 30 and 100. And that means to find this one, we would do 180 subtract that, which ends up just being 30 and 100. Okay, so this is always going to be the sum of these two. Okay, so our angle Y is 130, and it's because they're external angles in a triangle. Okay, so that says that down below. Yeah. Polygons. Remember about polygons? The word regular means that they're all lengths of the same size. Yes. All lengths are the same size.
Same length.
All sides are the same length. Yeah, I did that's not what I said. It's a bit worrying. Right, three sides. What's a three-sided shape called, Brianna?
A triangle.
Yo. Mia, what's a four-sided shape called? No. Awkward. Real, and round. What's a five-sided shape called? Not quite as many noises now. We're starting to get a little bit quieter. It's a hexagon. Hexagon, not septagon. Yes. Hexagon. Eight sides. Octagon. Then 9 sides. Just decagon. Oh, I never remember 11.
Isn't dodecagon 12?
Yeah, dodecagon. I always forget 11. I think it's on the next page, isn't it?
Why are they all in the gone? Siri, I think it's on and on there.
It's like So it's something different.
No, it's Decker.
We'll find out what it is later.
And it has, sorry to disturb your brain work, but I'm really cool. Can we look up what it was?
Oh, it's